Welcome everybody. Today we are going to talk about permutations and combinations and how this relates to probability. Okay. With probability, we have been interested in finding out pretty much in fraction form or decimal form what the probability of something happening is. Now we're trying to figure out how many total outcomes an experiment can have. And when we talk about total outcomes, we're going to talk about permutations or what we call combinations. With permutations, the order matters. With a combination, order does not matter. So for example, if we were talking about a locker, okay, you had a lock that you were going to put on a locker. We've always called this a locker combination, but honestly it should be called the locker permutation because the order matters in how you open up that lock in order for it to open. So with a permutation, we have the formula NPR, and what N is going to represent in the formula is the total number. Okay, the total number of items that we want to arrange. And R is going to stand for how many we are going to arrange. With a combination, NCR, okay, we have the formula n factorial, n minus r factorial, and then r factorial. Now to understand what a factorial is, okay, what that symbol means is, for example, if we had 7 factorial, that would mean 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And the quickest way that you're going to be able to find a factorial in your calculator, okay, if you have a graphing calculator, if you hit type 7 and you go to the math button, if you arrow over to probability, you're going to see a permutation button, a combination button, and a factorial button. So if I hit number 4 for the factorial button, 7 factorial is going to be 5,040. Okay? And again, that's just if you multiplied 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? 3 factorial would just be 3 times 2 times 1, which would be 6. Okay? So let's take the example where we have the letters A, B, C, D. Okay? So I have 4 letters and I want to select 2 letters. Okay? So if I was going to select 2 letters out of these 4, I could say 4 permutation 2. Okay? And again, in my calculator, I would type in 4, I would hit the math button, I would go over to PRB, go to permutation, and then hit the 2 button. 4 permutation 2 is going to be 12. Now if I was treating this as a combination, okay, if I type in 4 math PRB and I hit 3 for the combination button, 4 combination 2 is going to be 6 possibilities. Now we're going to show you why there's 12 possibilities and why there's 6 possibilities. Okay? If I was going to select 2 letters, I could start off saying, all right, starting with A, I could select AB, AC, AD. And then with B, I could select BC, BD. And if I start with C, I could select CD. Now, if order matters, that means AB and BA are different. AC and CA are different. So when I flip these letters around, that's a different order. And that's why I have 12 possibilities there. With a combination, we don't care what the order is, so there's only 6 possibilities with a combination, because A, B, and BA mean the same thing if the order doesn't matter. Okay. So most of the time we're not going to draw it out. Okay, that was just to show you the possibility. What you have to understand the problem is it a combination problem or is it a permutation problem? So if we take a second example, okay, let's say that we're talking about the lottery. Okay, we're talking about Powerball. Okay, Powerball is a lottery you can play in Connecticut. And with the Powerball lottery, okay, there are 70 numbers. Okay, and for you to win, okay, out of those 70 numbers, you have to pick 5 numbers. Okay, then out of the 26 Powerball numbers, you have to be able to pick that one number correctly. And again, the reason why this would be a combination is because we don't care what order those numbers come up. If you have those 6 numbers, it doesn't matter how the ping pong balls come up, you're going to win. So 70, again, if we go to math, PRB, combination, 70 combination 5, okay, again, if we look at that number, 12,103,014, and if we do 26 combination 1, that's just going to be 26. So if I multiply that by 26, 314,607,364 total outcomes. Okay, that's how many different combinations there are that can come up in the Powerball. That's why if you buy one ticket, the probability of you winning that is 1 divided by that. Okay, a very small probability, obviously. But again, we want to figure out the total outcomes. We're going to use a combination or a permutation. Now with a permutation, okay, give you an example of that. If we said that we have 6 people running for office, okay, and we're going to choose 3 people. But one person is going to be the president, one person is going to be the VP, and one person is going to be the treasurer. So there's a specific order to that. So when we have an order like that, we have to use a permutation. So we have 6 outcomes, and if we do 6 permutation 3, okay, that means that there are 120 possible outcomes that could happen. But again, because we're picking the order of those people, that's why we have to use a permutation. Okay, so when order matters, permutation. When order doesn't matter, like the lottery, combination. In our next video, we'll be talking about factorials a little bit more and how to find the total outcomes of an experiment using the factorial.